Welcome to Demystifying Math. In this lesson, we're going to be solving trigonometric equations. Basically, what we're going to do is try to find exact values for angle measures given an equation. We're going to use the unit circle to find those angle measures, and then we're going to generalize our solutions by rewriting them as an equation. So we're going to start off with the cosine of x equals 0. You're going to look on your unit circle for where your cosine is 0. Remember that your x-coordinate represents your cosine and your y-coordinate represents your sine. So that means that the cosine of x is equal to 0 when x is equal to pi over 2 or 3 pi over 2. Now we would also have solutions for any angles that are coterminal to pi over 2 or 3 pi over 2. So I tacked on 5 pi over 2 and 7 pi over 2, and you can keep going on forever and ever. But what our goal is to find all possible solutions by giving an equation for them. So if you look at the distance going from pi over 2 to 3 pi over 2, you would be going pi radians. And if you go from 3 pi over 2 back up to pi over 2, or what we would say is 5 pi over 2, that's adding another pi to that. So if we continually add pi to pi over 2, we would get all the angles that are solutions for cosine x equals 0. So we can say that x equals pi over 2 plus pi n, where n is any integer. Next, we're going to look at the sine of x equal to 1/2. So again, we're going to go to our unit circle and look where we have 1/2 for the y value. So you can see that's going to happen at pi over 6. There's also another solution at 5 pi over 6. For the angles below the x-axis, we're not going to have a solution because our y value is negative there. So on the interval from 0 to 2 pi, we have two solutions of pi over 6 and 5 pi over 6. Now what we want to do is include all their coterminal angles. So their coterminal angles would be when we add 2 pi to those angles, or if we continually add 2 pi to those angles. So we have x equals pi over 6 plus 2 pi n, or x equals 5 pi over 6 plus 2 pi n. So we have two different equations, but they're both representing the solutions. So we have to give both of them if we want to get all possible solutions. Let's look at the tan of x equal to 1. Remember that the tan of x is equal to the sine divided by the cosine. So it's going to equal 1 where the sine and the cosine have equal values. And that's going to happen at pi over 4, where the sine and the cosine are both square root of 2 over 2. It's also going to happen at 5 pi over 4, where the sine and the cosine are both negative square root of 2 over 2. So if we divide the two negatives, we still get a positive 1. So we have two solutions between 0 and 2 pi, of 5 pi over 4 and pi over 4. Now we want to generalize those solutions and get all their coterminal angles. So if you look at the distance between pi over 4 and 5 pi over 4, you would be going pi units. Then if you go another pi units, you're going to get back to pi over 4, or the coterminal angle to pi over 4. So in this case, all we have to do is add pi n to our pi over 4, and it's going to give us all possible solutions for the tan of x equals 1. Our next problem is 2 times the sine of x equals the square root of 3. We have a little bit of simplifying to do before we start this problem. So we're going to divide both sides by 2. Now we're looking where the sine of x is equal to the square root of 3 over 2. Remember, the sine is the y value. So go around your unit circle and look for any y values that are square root of 3 over 2. So we see that at pi over 3 we have a solution. We also have a solution at 2 pi over 3. So between 0 and 2 pi, those are our two solutions. Again, below the x-axis, the sign is negative, so we don't have any solutions there. And there's no easy way for us to write the distance between pi over 3 and 2 pi over 3, and then the distance all the way back around to pi over 3. It's a big difference between the distances. So in this case, what we have to do is express them as two separate equations. So pi over 3 and all its coterminal angles is going to be pi over 3 plus 2 pi n, And 2 pi over 3 plus all its coterminal angles is going to be 2 pi over 3 plus 2 pi n. Our next problem is 2 times the cosine of 3x equals negative 1. So again, we're going to isolate our cosine, and we get the cosine of 3x equals negative 1/2. We're going to work this problem the same way we did the other ones. We're going to look to see where we have negative 1/2 on our unit circle for cosine, our x value. So that's going to have to be in quadrants 2 and 3, where the cosine is negative or the x values are negative. So we have 2 pi over 3, and we have 4 pi over 3. Then I also added some more coterminal angles to those, and you're going to see why in a minute. Remember that this angle measure was 3x, not simply x. And if we want to get all the solutions between 0 and 2 pi for x, we have to do 3 times as many for 3x. So what I did was I went around the unit circle 3 times, finding coterminal angles to 2 pi over 3 and 4 pi over 3. Now to isolate x, I would divide both sides of the equation by 3, or multiply by 1/3. So we're getting angles of 2 pi over 9, 4 pi over 9, 8 pi over 9, and so on. So the 16 pi over 9 is still less than 2 pi. If I went one more angle, I'd be greater than 2 pi. So that's where I'm going to stop. Now we have to express this as an equation, or equations. So looking at the 3x, if we look at 2 pi over 3 and all its coterminal angles, that would give us 2 pi over 3 plus 2 pi n. Then all I have to do is divide both sides of the equation by 3, or multiply both sides by 1/3. So we get 2 pi over 9 plus 2/3 pi n. Or we're going to look at all the coterminal angles to the second angle that we found, which was 4 pi over 3. So we're adding 2 pi into that, and that's going to give us all the solutions for 3x. But since we want all the solutions for x, we're going to divide or multiply by 1/3. So that's going to give us 4 pi over 9 plus 2/3 pi n. You can also think about it this way. When you have the cosine of 3x, you've changed the period of your function. Your period is normally 2 pi. So we would divide 2 pi by 3 to get the new period. So that's where the 2/3 pi is coming into play there. So that's adding a period of the new function to the angle that you found. Our next problem is 3 times the tan of x over 2 equals square root of 3. So we're going to simplify that again. So we're isolating the tan of x over 2. Now we need to find out where the tan is equal to the square root of 3 over 2. So we know that the tan is equal to the sine over the cosine. So we're going to look at pi over 6. If we take the sine of pi over 6, which is 1/2, and divide it by the cosine of pi over 6, which is square root of 3 over 2, and then simplify it, we get square root of 3 over 3, which is what we're looking for. So we have one solution at pi over 6. We need another solution, and we know that the period of the tan is pi. So if we go pi units around the circle, we should get another one, and that one's going to be at 7 pi over 6. Those are two solutions for x over 2. Again, we want to find all the solutions for x between 0 and 2 pi. So we're going to multiply both sides by 2. So we get 2 pi over 6 and 14 pi over 6. Well, 14 pi over 6 is greater than 2 pi. So if we only want the solutions between 0 and 2 pi, we're going to leave out that last one. So our only solution between 0 and 2 pi is pi over 3. Now what we want to do is generalize that. So we have all solutions for x over 2 to be pi over 6 plus pi n using our period. And then we're going to multiply both sides by 2. So you have pi over 3 plus 2 pi n. It's going to give you all possible solutions for 3 tan of x over 2 equals square root of 3. For our last problem, we're going to solve for the secant squared of x equal 2. Now, you can think about it this way. The secant is equal to the reciprocal of the cosine. So if we take the reciprocal of both sides of the equation, we get cosine squared x equals 1/2. Then we can take the square root of both sides and get the cosine of x is equal to plus or minus the square root of 1/2, or rationalized as plus or minus the square root of 2 over 2. Now, in this case, we get positive or negative square root of 2 over 2. So between 0 and 2 pi, we have 4 solutions. Pi over 4 is a positive square root of 2 over 2. The 3 pi over 4 is the negative square root of 2 over 2. And then you also have 5 pi over 4 and 7 pi over 4. So these are all separated by pi over 2 units. So you have pi over 4 plus pi over 2n as all your possible solutions. Okay, thank you for tuning in to Demystifying Math.